All right, let's go ahead and go over this. So for here, we are working through some of our problems from product of our powers. So for here, what we want to do again is we want to identify each of these separate components that we can actually work through. So if we're looking at problem number 1, we've got a -2 and we have a 2 to the 5th power that we can actually work through separately. So we have a -2 and we have a 2 to the 5th power. So we're going to go ahead and work those problems out separately as if it's its own. So we're going to do -2 times 2 to the 5th. Now 2 to the 5th is just going to give us 32. So we're going to really be doing -2 times 32. And -2 times 32 is going to come out to a -64. So we should have a number component of -64 for here. Computer froze. All right, so should have gotten the -64. Now we're going to look at the variable components. So our first variable component that we've got is this x to the 5th and x. So we're going to be focusing on those as a separate problem. We have x to the 5th times x, which is really x to the 1st power. That means what we're going to be doing is x to the 5 plus 1 power, and that becomes x to the 6th. Okay, then we will focus on the next set of variables. We've got y to the 4th and y. So we're going to do y to the 4th times y, which is really like y to the 1st. That means we're going to be adding those exponents together, 4 plus 1, and that becomes y to the 5th power. The only one that we still have that does not have a component to be multiplied with is that z to the 3rd. That one is all on its lonesome. So it's just going to come down as z to the 3rd. So then there's our entire answer. And I'll piece it all together as just one single color so that you can see that they all belong together. It's -64, x to the 6th, y to the 5th, z to the 3rd. Okay, for our second problem, problem number 2, we have a fraction, but notice that the fraction itself is not inside of parentheses. So that means that that exponent is only going to belong to the 3. The exponent is only going to belong to that 3. So we're going to focus on our values, our number values first. We've got 3/4 to the 3rd power and 2/3 or 2 to the 3rd power. So we're going to focus on those first. So when we've got 3/4 and it's raised to the 3rd power without parentheses times 2 to the 3rd power, or cubed, this essentially means that we are doing 3 times 3 times 3/4 and then multiplying the whole thing by 2 times 2 times 2. Okay, so 3 times 3 times 3 is going to be 27/4. And then 2 times 2 times 2, that's going to come out to 8. And when we multiply that entire thing together, that's going to come out to 54. 27/4 times it by 8 is just going to come out to 54 as a whole. Okay? Now we can focus on the variables. We've got x to the 4th and x. X to the 4th times x, which is like x to the 1st. That becomes x to the 4 plus 1 power, which is going to become x to the 5th power. Then we've got y to the 2nd times y. Y to the 2nd times y to the 1st. All you're going to be doing is adding those exponents, and that becomes y to the 3rd. And then, of course, z is all by its lonesome. It has absolutely nothing with it. So it just comes down as z. You could write z to the 1st, but it's really not necessary. So your entire answer should be 54, x to the 5th, y to the 3rd, Z. Okay, so that was our product of powers. We're going to get into quotient of powers. What does quotient mean? What operation is quotient, guys? Division. So we're going to be talking about dividing powers. So taking a look here, if we've got 2 to the 7th divided by 2 to the 4th, right? It's written as a fraction. Fractions mean division. So if we've got 2 to the 7th divided by 2 to the 4th, and again, I'm just going to write them out like we did yesterday, where we have all these 2's. We've got 7 2's on top. 1, 2, 3, 4, 5, 6, 7. And then on the bottom, we've got 2 to the 4th. So that means we've got 1, 2, 3, 4 different 2's. Okay? So when we've got a situation like this, I can cancel that set of 2's out. I can cancel that set of 2's out. I can cancel that set of 2's. I can cancel that set of 2's. And now I have nothing left to cancel on the bottom. However, remember, there's always an invisible value there. What invisible value is always there? A 1, right? There's always an invisible 1 here. So I'm going to go ahead and just place a 1 underneath it so that I know that there is a value that exists. It's not a 0, because if you put a 0 on there, it means it's going to be an error. You're going to get an undefined value. Okay, so there's technically an invisible 1 still remaining. But what are we left with here? We're left with a bunch of 2's to what power? To the 3rd power, right? There's 3 2's that are remaining. So this is left as 2 to the 3rd power. I don't have to write over 1 because, again, it's an invisible math. So I'm left with it as 2 to the 3rd power. Same thing if I were to do this with the x's. I have 9 x's, right? X to the 9th. X times 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 x. I've got 9 x's on the top. And then I've got x squared on the bottom. So just x times x. So for every x that I have on top, I can cancel it with one of them on the bottom. So I can cancel 2 sets of x's on top and bottom. How many x's does that leave me with? 7. So that becomes x to the 7th power. Again, there's an invisible 1 underneath, but I don't have to write it. So talk with a partner. What do you think the rule is when we are dividing, when we're doing quotients of powers? What do you think the rule is going to be? All right, who wants to tell me what they think the rule is going to be? If it's a quotient of powers, what are we going to actually be doing? Yo-chan? What are we doing? We're subtracting, right? And what are we subtracting? The exponents, right? Are we doing anything to the base? No, the basis is going to stay the same. Now, what do you think? If this was 2 to the 7th over 3 to the 4th, could we then subtract? If it was 2 to the 7th over 3 to the 4th, could we subtract the exponents? No, because they're not the same base. So it's important to remember that the bases have to remain the same. So let's go ahead and write that rule down. When dividing, when you are dividing powers of identical bases, they have to be identical, they have to be the same. You subtract the exponent. And keep the base. Right? The base is not going to change. You keep the base just as it is. You are just subtracting what the exponents are. And then just like yesterday, I want to go ahead and make sure that you understand that there is a flashcard rule that you should be making on your own. You should eventually be making a set of flashcards for yourself. On the front of your flashcard, you will write down the title of the rule, which is Quotient of powers. And what it looks like, it's written as x to the m power divided by x to the n power. This is what it looks like. This is the setup of a quotient of powers. On the back, you would write down what you would be doing, that you would actually take x, and the exponent would be the m minus n power. Okay, so go ahead and get that written down. All right, let's go ahead and flip it on over to the back. We're going to do a couple practice problems. So for problem number 1, we've got -7 that's inside of parentheses to the 9th power over -7 that's inside parentheses to the 6th power. So all we are doing in a case like this is we are taking the -7 and we are subtracting the exponents 9 minus 6. 9 minus 6 is going to come out to a positive 3. And then, of course, we could simplify it even further by solving for -7 to the 3rd power. -7 times -7 is going to be a positive 49. And then multiplied by another -7, that's going to come out to a negative 343. Okay, we're just solving it all the way to the fullest extent that we possibly can. Okay, I'm going to skip number 2. I'm going to let you guys do number 2 on your own. Can I get rid of this first sheet? Yeah? Okay, good. So that way I can zoom in so you guys can see easier, because some of you in the back are not able to see. Okay? All right, for problem number 3, we've got a couple of number values here. We've got we've got 72 over 3. So I'm going to separate these out as different problems. That's why I do it in different colors. I'm going to focus on doing 72 divided by 3. What is 72 divided by 3 going to give me, guys? 24. Very good. So we have 24 for that answer. Okay, now I've got some variable ones. I've got x to the 4th over x. X to the 4th over x, which is like x to the 1st power. So what I'm going to do is I'm going to take my variable and I'm going to subtract my exponents. I'm going to do 4 minus 1, which comes out to x to the 3rd power. Then I've got these y's. I've got y to the 5th and y. So that's a separate problem. Y to the 5th over y to the 1st is a separate problem. I'm actually going to be subtracting those exponents. I'm going to do 5 minus 1, and that gives me y to the 4th power. So my final answer here is 24, x to the 3rd, y to the 4th. What I want you guys to do is do problem 2, 4, 5, and 6 on your own, please. All right, problem number 2. Who can tell me what is x to the 8th over x to the 6th going to equal, Veronica? X to the 2nd power. X to the 2nd power. So for here, all we're going to be doing is subtracting these exponents. We're going to take the 8 and subtract the 6. That's going to give us x to the 2nd power. What about for problem number 4? We've got 3 to the 4th, a to the 10th, d to the 5th, divided by 3 to the 2nd, a to the 8th, d to the 4th. What is that final answer going to be, Ray?
9a to the 2nd and d.
Very good. 9a to the 2nd, d. So here, we've got 3 to the 4th over 3 to the 2nd. That's the first thing that we're going to focus on. 3 to the 4th power over 3 to the 2nd power means that we are going to keep the 3 and subtract the exponents. We're going to do 4 minus the 2. which comes out to 3 to the second power. But 3 to the second power can be simplified to a 9, right? 3 times 3, that's going to give you 9. Then we're going to focus on the a's. We have a to the 10th and a to the 8th. So a to the 10th over a to the 8th means that we're going to keep the a and subtract the exponents, subtract the 10 minus the 8, and that's going to come out to a to the second power. Then for the d's, d to the 5th over d to the 4th. That means that we're going to subtract the exponents, so we're going to subtract 5 minus 4. That's going to come out to d to the first, or just d. So when we piece it all together, that's 9a squared d. Okay? Problem number 5. We have 3 to the 4th times 3 to the 2nd over 3 to the 3rd. What is the final fully answered answer going to be? Bridget? 27. Okay? The first thing that you're going to actually want to do is the product rule, right? This is a combination of product and quotient. So you're probably going to want to do the product rule first. 3 to the 4th times 3 to the 2nd means that what you're really going to be doing is adding those exponents. So you're focusing on doing 4 plus the 2, which is going to come out to 6. So we get 3 to the 6th over 3 to the 3rd. Then we can go ahead and subtract the exponents. 6 minus 3 comes out to 3 to the 3rd power. But 3 to the 3rd power, as we know, is just 27. Okay? So you want to combine the top exponents first together because they are of the same base. Then you can do your quotient rule. Okay? Problem number 6. We have a to the 10th over a to the 6th times a to the 7th over a to the 4th. Armando, what did you get? A to the 7th power. Good. There's two different ways that you could go about it. You could either do the product rule first by doing 10 plus 7 and then 6 plus 4 and then subtract. Or you could do the quotient rule first. You could do 10 minus 6 and then 7 minus 4 and then do the product rule, which would be to add. Either one of those would have been perfectly fine. So I'm going to do the quotient rule first. I'm going to do a to the 10 minus 6 power, which comes out to a to the 4th. Then I'm going to do the a to the 7 minus 4th power, which comes out to a to the 3rd. Then I'm going to go ahead and do my product rule, which is to add 4 and 3 together, which comes out to a to the 7th. Okay? On Google Classroom, you have a quizzes on quotient of powers. Go ahead and get started.